questions. So we are dealing with geometric sums again, and find the least value of n such that 1 plus 2 plus 4 plus 8 blah 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 to n terms would exceed 2 million. So what's the first number in the sequence that sends the total over 2 million? So the first thing to do, okay, would be to get this key information. So we can see A from the question itself. We can see R quite clearly from the relationship between them. N's what we're trying to find out, and we've set up our inequality. It needs to exceed 2 million. Okay, so first thing to do in terms of solving it would be to plug our numbers into this equation here. So what have we got? We've got 1, I'm going to use the red one, 1 multiplied by 1 minus r was 2, to the power of n, all divided by 1 minus 2, so that's minus 1, isn't it? If I'm just sort of skipping that part there. This is the sum, and this is going to be greater than 2 million. Okay, so a few things we can do. We can get rid of that straight away. We can just make this a negative, so you can do this a few ways. I'm just going to change the order of the things in the brackets. That will do it. So 2 to the n minus 1 is greater than 2 million. So 2 to the n is greater than 2 million and 1. So we could do lots of different things here, but let's talk about the easiest way. So I'm trying to access n. I'm trying to solve an equation with, well, solve an inequality here with n, and it's in the power, and I can't access it. So what do? Well, I use logs, okay? I'm going to use log base 2. So log base 2 of 2n, what you can do is you can bring the n down to the front, is bigger than 2 million and 1, and I need to do logs of both sides. So log 2 of 2 million and 1. What power of 2 is 2? It's 1, so this disappears here. So actually I just need to work out this part here, and you should get something like n is greater than 20.9. I've just truncated it. Okay, so what's the first term that's greater than 20.9? Well, it's n equals 21, isn't it? Okay, let's have another look at a quick one, but it's going to be the same process. So next one we're going to do, and just to save some time, I'm going to tell you that the ratio equals 3/4, and the first term is going to be 256. The smallest value of n such that the sum of the first n terms exceeds 1,000. So it's going to be something like this, isn't it? Okay. Let's give you a little bit of that working out. So let's give you this part here. Okay. And when I substitute in, without doing the whole question for you, can you see that the question is going to involve simplifying and bringing this up? It's going to involve dividing by this number, and ultimately it's going to involve something with this here, okay? With some kind of complicated expression here on the right hand side. Just one note for this that you do need to be careful of. You might be tempted, as we did before, to take log the base of the same base for the n that you want to bring down. So you might be tempted to try log of 0.75 here, but that won't work. Okay, you need to be very careful of using logs lower than base 1. But it's fine. All you need to do is you need to use, say, log base 10. Okay, log base 10. Keep all of this stuff over here and just divide at the end by this number, and again you should be able to get your result, n equals 14.